A body with definite shape and size that does not change on application of an external force is called a rigid body. On applying external force, the distance between any two particles of a rigid body remains same. In practice, no body is perfectly rigid, but the bodies in which deformation on applying external force is negligible are considered to be rigid bodies. Center of mass of a body is the point where entire mass of the body is concentrated. It is an imaginary point, and any mass of the body may or may not be present at this point. The position vector of center of mass of two particles is given as r is equal to m1r1 plus m2r2 upon m1 plus m2. For a system of n particles, the center of mass is given as r is equal to sigma mi ri upon m, where I is equal to 1 to n. A body in which mass is distributed uniformly is called a homogeneous body. The center of mass of homogeneous bodies lies at their geometric center. The center of mass of a system of particles moves as if all the external forces are applied at this point, and entire mass of the system is concentrated here. A body is said to have uniform angular velocity if it rotates through equal angles in equal time intervals. In rotational motion, the angular velocity of all the particles of a system is same, whereas their linear velocity is different. The linear velocity of a particle depends on the distance of the particle from the axis of rotation. Greater the distance from the axis of rotation, higher will be the linear velocity of the particle. The relation between the angular velocity omega and linear velocity v is given as v is equal to r omega, where r is the distance from the axis of rotation. Angular acceleration of a particle under rotational motion is defined as the rate change of angular velocity and is given as alpha is equal to d omega upon dt. Torque is the rotational analog of the force. It is defined as the turning effect of a force, and its magnitude is given as the product of force and perpendicular distance of the line of action of the force from the axis of rotation. Mathematically, torque is given as tau is equal to r cross F, where F is the force acting on the system and r is the perpendicular distance of the line of action of force from the axis of rotation. Angular momentum is the rotational analog of the linear momentum. The angular momentum of a particle is defined as product of its linear momentum and distance of the particle from the axis of rotation and is given as L is equal to R into P. As in the case of translatory motion, a net force on a body causes a change in its linear momentum. In case of rotational motion, a net torque on a system causes a change in its angular momentum. The relation between the torque and the angular momentum of a body is given as tau external is equal to d upon dt L. According to the law of conservation of angular momentum, in absence of a net external torque, the total angular momentum of a system remains constant. If systems does not have a linear acceleration and angular acceleration, the body is said to be in mechanical equilibrium. A body can be kept in pure rotational motion by a pair of equal and opposite forces with different lines of action. Such pair of forces is called couple or torque. The body under effect of a torque does not possess any translational motion. Center of gravity of a system is the point at which entire weight of the system acts. The total gravitational at this point is 0. Moment of inertia of a body is the sum of product of masses of all the particles and square of their respective perpendicular distance from the axis of rotation, and is given as I is equal to sigma m jrg squared, where j is equal to 1 to n. Moment of inertial is the rotational analog of the mass. Moment of inertia of some objects are shown here.